This is 4.3. So there are 6 problems. So you need to fill out a table here. So you're going to plug in whatever that x value is. And sometimes when you plug in the x value, it doesn't work. So if I put a 49 in there, the square root of 49 is 7, and 7 minus 5 is going to be 2. If I plug in 0, square root of 0 is 0, minus 5 is negative 5. But when I try to plug in negative 9, the square root of negative 9 is an imaginary number. So that one has, you're supposed to click the not a real number option. All right. All right, domain of a square root. So if I have the square root of x plus 9, are there any numbers I'm not allowed to plug in? What if I plug in 3? Is that going to give me an answer? Yeah, it won't be a very friendly answer, but 3 plus 9 is 12. The square root of 12 is going to be like 3.2. Okay. All right. What if I try to plug in negative 6? Negative 6 plus 9 is 3, and the square root of 3 is 1.6 something. I don't remember. Okay. But what if I try to plug in negative 11? Negative 11 plus 9 is negative 2. Can I take the square root of negative 2? Not using real numbers. So negative 11 is out. And this question is asking us, find the domain, which means tell me every single x I'm allowed to plug in. So 0 to, not 0. So I can plug in 3, but I can't plug in negative 11. What about negative 8? Would negative 8 be okay? Yes. What? From negative 9 actually to infinity. Right? Any positive number is going to work here. But negative 9 is the magic number. Am I allowed to plug in negative 9? Negative 9, if I stick a negative 9 right here, negative 9 plus 9 is 0. Can you take the square root of 0? Yes, you can. It's 0. So if I were to draw the number line, the magic number is 9. And you guys said 9 counts. Nope. Yeah, negative 9. So every one of those works. Anything from negative 9 to the right works. But anything left of negative 9 doesn't work. How do we represent that as an inequality? X is greater than or equal to negative 9. Okay? So what's the easiest way to figure that out? Here's what we do. We know that this has to give me either a positive number or 0. So what we do is we take the stuff on the inside, x plus 9, and we write greater than or equal to 0, and then we solve for x. X is greater than or equal to negative 9. So let's look at one that's a little bit more complicated. What am I allowed to plug in? Well, I take this stuff and I say 2x minus 12. has to be greater than or equal to 0, then I just solve. Plus 12. 2x is greater than or equal to 12. Then we divide by 2. And I get x is greater than or equal to 6. Does that make sense? So if you want to know the domain of a square root, take the inside and set it greater than or equal to 0. All right, what about this one, though? Something a little bit weird happens here. I set the inside greater than or equal to 0. What should I do now? I turned it off. Oops. So, which one do I move first? 15. Negative 3x is greater than or equal to negative 15. Ah, good. When I divide by negative 3, now I say x, and because I divided by negative, I have to flip the inequality. So that says any x smaller than or equal to 5 will work. Let me show you why. Let's plug in 4. And I get 15 minus 12. Is that okay? Yeah, 15 minus 12 is positive, so that will work. But let's plug a number that's not in there. Let's try 6. When I plug 6 in there, I get 15 minus 18. Is that okay? No. That breaks the rule. So anytime you're dealing with an inequality and you multiply or divide by negative, you need to flip the inequality. Okay. What does it mean to take the cubed root? You need 3 copies instead of 2 copies. So let's plug in negative 65. I get the cubed root of negative 65 plus 1, which is the cubed root of negative 64. Uh-oh. Is that not possible? No. You can do the cubed root of a negative. You cannot take the square root of a negative and get a real number, but a cubed root you can. How come? There are 3 of them, and 3 negatives make... Try again. Negative. So in this case, the cubed root of negative 64 is just going to be negative 4. Because negative 4 times negative 4 is 16, times negative 4 is negative 64. So there are no i's in cubed roots. Okay, how do we graph a square root? So the normal square root graph looks like this. It starts at 0, 0. And then the next nice point is the square root of 1, which is 1. And then the square root of 2 is not a very nice number. What's the next square root that is nice? 4. So we go out to 1, 2, 3, 4. And what's the square root of 4? 2. And then what's the next one after that? 9. And what's the square root of 9? 3. So the first one is 1, 1. The second one is 4, 2. And the third one is 9, 3. Okay? Now, the other thing you need to know is if we have x plus or minus something, this number is going to shift the graph to the right or to the left. And then if on the outside we have plus or minus something, this number is going to shift the graph up or down. However, the left and right is always backwards. Can you guys remember that? We've done that before, right? The left and right is backwards. The up and down is not. So in this case, how far left and right are we going to shift this? Or not? Okay. How far up and down are we going to shift it? Up 7. So the starting point is up here at 7, and then we just follow that pattern. Over 1, up 1. Over 4, up 2. And over 9, up 3. So if I put those 4 points, I don't know if that worked or not. Nope. Okay, so 7, maybe. Okay. Does that make sense? So you have to graph the starting point, and then you have to graph the other. You have to graph 3 more points. All right. What if it looked like this? Where is the starting point of that square root? -1, -4. So remember that is backwards. So left 1, down 4. And then we use the same pattern. Over 1, up 1, over 4, up 2, over 9, up 3. Okay. Oh, look at that. That is the exact problem we just did. What are the chances? Do you want to see another one? No? Okay. All right, get to work.